It's time for a review of some of the things you've already talked about, but we're dealing with how you program in SQL Server for real-world applications, so to speak. This is reflecting the most common approaches that are used when you're designing stored procedures to support some sort of a client application. Works well with a web client or Windows client, anything where you're creating an application where people are bringing records up on the screen to edit, to insert, to delete, etc. Okay, so just to move forward then, what we're going to do is, as part of this review, there's some basics that we need to get covered and out of the way, kind of assumptions, you might say. One of the things that we deal with when we write stored procedures is there's this option of no count. You probably talked about this already, but you may not remember. For data returning queries, anything that has a select statement that returns data when you execute the stored procedure, we typically will set no count to on because that suppresses a second message sent down to the client. The first one returns the data, and a second message returns information about how many records were affected. Well, we don't need that because we already have the data. We can see how many records were there. So it just saves a bit of network traffic, eliminating that extra step, right? On the other hand, for the action queries, for the insert, update, and delete queries, we may or may not, but typically not part of the stored procedure is to return the data again, certainly not to return all of it or anything like that. So we typically will set no count to off. And that allows this message to be sent back, which can be a confirmation of success, right? Because by knowing how many rows were affected by insert, update, or delete, it can give us an idea of exactly what happened in the database server itself, right? Then you could communicate that in various different ways, but this is a simple built-in method for that, and that's all you need to do. Okay. And just before we go on to discuss the sort of recipes for these standard stored procedures, just a couple things to review about how we build tables for this scenario, right? We often, in the real world, will implement a dual key system. That means that there will often be one or more fields in a table that represent uniqueness, right? Or perhaps it's actually a business rule that, this field or this combination of fields must be unique. Well, that right away is a good candidate to be a primary key, of course. The problem with that situation is often you don't get the best efficiency, right? So typically what we'll do is we'll add our own, what we sometimes call the programmer's key, right? And that is typically something like an integer identity or perhaps a globally unique identifier. And it's something that doesn't actually describe anything about the data itself. It's just a quick way to refer to a record in our programming code. Along with that, we still call it a dual key system because you'll still be concerned about implementing any business rules that are required. For example, if a combination of two or three fields has to be unique, well, then we'll typically do that with a secondary index, for example. Okay, concurrency control, not every table needs it, not every database needs it, but if there's going to be a fair number of users working in the system at the same time, it is important to consider concurrency control. And on the tables that are going to have the highest number of transactions happening, the most traffic, so to speak, then we would usually go that route. I know you've talked in the past about different approaches, compare all values and so on, but timestamps are often used because they're more efficient in many ways. Okay. And basic auditing requirements, right? Again, real world programming, usually there's some need to be able to track certain information about who and when changes are happening in the system. Now, this can be extensive information being logged, could be even before and after versions of records on every change. That's the most extreme type of form, and we'll often see that in financial systems, banking, and so on. But, at the most basic level, often we're concerned first and foremost with who last changed a record and when, and possibly along with that, who initially created the record and when, right? Okay, so we'll be touching on all these different sort of table design issues as we go through. Okay, so Common stored procedures. There are a whole class of different ones that will return data, right? That have a select statement as the main operation of the stored procedure. Now, this could be returning a single record. Typically, then it's usually there's a where clause with a some identifier being used for the primary key, right, to return that one record. Multiple records could be returning all, or there might be some sort of filter, right? Or a combination of things that are being filtered on, records that have, this field starts with a given letter, or that a date is in a range of dates, things like that. And the last one is kind of unique, but comes up so often because of how we design user interfaces, is what I often call a lookup stored procedure or lookup data, right? Typically, this is presented in the user interface as drop-down lists, right? And for that, we just need two, count them, two fields returned. One is usually a unique identifier, most commonly the primary key, integer as it may be in many cases. And the second one could be one field possibly, but often it's a summary field, a combination, but put together into a single column, so to speak. And that is also typically sorted. The advantage of sorting it is twofold. For one thing, it makes it easy to find records, whether you're manually searching up and down, but you can also often type the first letter or sometimes multiple letters and jump to the record that way. And of course, that works best if it is sorted alphabetically by that summary field or display text, as it sometimes gets referred to. Okay, so there's different situations where we return data, but of course, there are actions, right? Our CRUD operations, as we often call them. Insert, update, and delete. Now, when we're talking about this style of preparing a backend for a user interface, typically these action queries focus on a single, uno, one, as in less than two records at a time, right? So we insert a new record, or we update a specific record, delete a specific record, and so on, right? Of course, insert, update, and delete can work on multiple records, but typically this is the most efficient way to set up your stored procedures so they work with how the user interface is likely going to present information and work with information for the user. Okay, just a quick review then, a few more details about select procedures. So if there's no where clause, right, um, then it's just quite simple. But the other aspect is we may not want to just work directly with the key table involved or the main entity we're focusing on. Sometimes we'll create a view in the database. And what this does is it allows us to eagerly load or pack additional information that will be useful in the user interface, right? So the program doesn't have to come back a second or third time to get extra information to show on the screen. It's all eagerly loaded into the one result set returned by the view. Okay. And obviously selecting by primary key value, you return one record at a time, right? And of course, we'll have lots of different variations of select procedures that have different filter criteria. And we'll even touch upon some examples of that before we're done. Okay, so the data manipulation language ones, the procedures that handle insert, update, and delete, typically the insert, one of the things that is usually done is if you're using something like an integer identity primary key or even a GUID, is let the client know what this new unique identifier, this new primary key value is. So that's often returned, sometimes as an output parameter or directly from the stored procedure. Update, right? If we talked about concurrency. So if there's a timestamp uh, to worry about, then we'll compare the timestamp parameter being passed in the where clause and only update the record if the record has not been modified by somebody else. And you can do the same with delete as well if you so desire. Often that's a design decision. Sometimes people aren't concerned about, hey, if somebody else deleted it, I'm not going to worry about what's going to happen here. It'll just fail, right? That's entirely up to you. Okay, so now we're going to go through a number of recipes, right? I've put these together as some recipes, sort of guidelines to follow on how to create the most common 5 standard stored procedures that you'll typically create on every single entity in the system. But before we get into the details of these recipes, I want to talk a bit about that idea of the view, right? And we're going to use two different examples, basically based on the same scenario, but with different levels of complexity. So we can fully flush out some examples of how to implement these recipes at the same time. So just let me get my SQL Server up here. Okay. So what I have is a very simple implementation of a movie database. The idea here is this is my collection of movies I have at home, right? So every movie I'm going to track the title, the year it was produced. Review stars is just like, is it a 4-star, 5-star? How good was it? And then the rating, okay, that's not the same as stars. That's talking about is it PG, PG-13? Is it G? Can I have all my grandchildren watch it and not have to worry about it? Things like that, right? So we have a separate lookup table, right? So it's a one-to-many relationship rating uh, to movie, right? So we have a foreign key rating ID in the movie table, right? So the movie ratings are, as I said, the textual representations of the different ratings like 14A and so on. Okay, so nice simple little design. But to go along with that, we're going to also use a bit more complicated scenario for some of our examples. So just to expand on that then, instead of just having a lookup for rating, we'll also have a lookup for movie format. So this is referring to, again, my library of movies. I've got old dusty ones sitting around on the shelf. Some are VHS tapes, some are Betamax, some are Laserdisc, then there's DVDs and Blu-rays and so on. So that's the different formats of the actual my copies of these different movies, right? And so we have those two foreign keys now, one for the rating and one for the format ID. But notice we've also thrown in a few different ones, concurrency, right? Timestamps, and just some very, very basic auditing for updated on and updated by, right? Now, this whole branch over here, this is reflecting the fact that in my database, I like to keep track of different people who are involved in the movie, right? So first, middle, last names, date of birth, and a bit of auditing information just so I know who's been editing these records. So the personnel then, of course, relate to the movie, but through this intersection table, because essentially you might say it's a many-to-many role. A movie's got many people involved, and a person might be involved in many movies. And the role of their involvement is kind of stored here with this third foreign key in our intersection table for the role table. The role description would be things like producer, director, leading man, leading lady, etc., things like that. Those are these different role descriptions. And the idea is, of course, that the same person could have multiple ways that they're involved in the same movie. Example, Tom Hanks, right? Tom Hanks has been for a number of movies the director, producer, and the leading man, right? So that would be three different records in our intersection table for the same movie, the same personnel ID, the same person, Tom Hanks, but with different roles, right? So, just talking about that for a second, it's clear that as a business rule, the combination of movie ID, personnel ID, and role ID would have to be unique. So we don't get any duplication of the same person in the same role in the same movie. We don't want to allow that, but we do need to have the unique constraint on all three so that you can have multiple roles for the same person in relation to the same movie and so on, right? Actually, when I'm talking about it, I should really mention as well that our movie table in the simple or the more advanced scenario should have a business rule here as well. Title and year produced, right? Wait, that combination should be unique. And so that would be an example of, in our dual key system, the business key, you might say. So why is that necessary to have that combination unique? Well, a lot of movies get remade, right? For example, Sabrina. Okay, that was a movie, one of my wife's favorites. I like it too, but I don't like to admit it. It was, I think, made in 1954 with Humphrey Bogart, Audrey Hepburn, and so on, and then made again in 1995. Harrison Ford, Julia Ormond. Anyway, so that's an example of a movie that's been remade a number of times, but in different years, right? So we do need to allow duplication of movie titles, but not the same movie in the same year, right? And that's a business rule there. Okay, so that's kind of an overview of the scenarios we're going to be working with. Now let's talk a little bit about the views that we would use here, right? Let me start with a simpler one. So here's an example of an eagerly loaded view in our simple movie system, right? Now, the general rule of these eagerly loaded views is you include all the fields of the actual entity or main table you're focused on. So that's why we have the ID, the title, year produced, stars, rating, etc., as well as from the related table, and here's our inner join to support the relationship. We're also going to pull from the rating table the textual description of the rating, the movie rating 14A, PG-13, etc., right? So that just gives us not only the fields from the movie table, but this lookup value as well being eagerly loaded. So we don't have to come back if we want to show beside the title, Sabrina 1995, rated PG-13, whatever it is. We don't have to go back to the database a second time to get that PG-13, that text that's already available. So that would be a simple one. Here's the more complex one. Same idea though. We have all the fields, right? But I've thrown in an extra one here because this is something we'll often do. This is an example of a summary, right? A summary field or summary column. So what we're doing is we're taking the title and the year produced based on the fact that, as we know, that combination has to be unique. So it takes the two to really describe fully a movie, right? To identify it to the user's eye. So by putting a little space, dash space between them, it can say, whatever the case is, right? Sabrina dash 1954, right? And that can be simply using as an alias movie. It can be the name of that column in our views output, right? All the rest is the same here, except of course we have two foreign keys, the format ID and the rating ID. And to go along with that, we have two actual foreign key values, right? Sorry, the actual related values, the lookup values, the actual name of the format, DVD, Blu-ray, and the name of the movie rating, PG-13, etc. Right? And then, of course, because we have our timestamp, we have to make sure that's included. And I'm throwing in as well our updated on and updated by. Who knows? We might want to even show that on the screen, right? Truth is, you can leave that out and still work with your auditing system, but I decided to include it in my view here. Now, my from clause have got, of course, two inner joins because we have the two lookup tables for format and rating. Okay, so that's a quick review then of what we're starting off with. I told you all that to tell you this, right? So let's get back to our PowerPoint. Okay. All right, so here's our first recipe, our select all. So, it's good to follow, you don't have to follow this, but make up your own naming convention if you want. USP is something some people use for a user stored procedure, and the name of the table or the entity, select all. So it might be movie select all, for example, right? Notice in our body of our stored procedure, we're going to set no count to on because it is a data returning stored procedure. And then we'll select all the fields from either our view or our table if we're using an eagerly loaded view. No where clause, as simple as could be, right? Let's get back to SQL Server. Okay, our simple movie select all then in our easy or simple version of our movie database. Notice set no count on is in here. We're just selecting everything in this case returned by the view, and that's all there is to it. No where clause. The slightly more complicated one isn't much different. I'm just setting no count on, selecting everything from the view. Notice how I decided in the end to leave out those audit fields. They're really not something that I'm going to display to the end user. If I wanted to, I could always modify the stored procedure later on, right? And that's getting the data without a where clause from our view. So our next recipe is to select by the primary key, right, returning one record at a time. So you see in the general recipe here, we have a parameter, which will of course respond or correspond to the primary key. And in my case, we're going with an integer data type, right, in our assumption here. Setting no count to on still, selecting whatever fields we require to show on the client from our viewer table, and our where clause is based on that primary key. So to see that in the database itself, so here's our simple one, right? So we've added the parameter to represent the primary key value that we want to select, right? And it's exactly the same as it was with just the added where clause. So no rocket science going on here. Basically the same thing in the more advanced one. Same projection, same from clause. We just added the where to correspond to the parameter. Okay, those are the easiest ones. Now let's move on to the next. So the third of our 5 standard sort procedures, of course, insert, then update, delete would be the fourth and the fifth, right? So with the insert recipe here, right, we have our tables. We're going to do an insert. So we have our series of parameters, right? But along with that, if we have any concurrency, sorry, not concurrency, blah, 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 audit, right? Updated by, created by, etc. We usually create nullable parameters so they can be passed in, but they don't have to be passed in. The data type in varchar 256, that corresponds well to what a lot of systems use for identifying usernames. It might be a email address, whatever. Okay? And of course, here's where we talked about passing back information about the newly generated primary key value, right? So in my case here, I'm going to use an output parameter. So we have that defined as an integer based on our integer identity primary key. Okay, setting no count to off this time. We just have our standard series of sets as part of our insert into table, right, for the various fields. Now, the other thing is we might set the updated by in case we don't have a value passed in. Null might not be acceptable, although if we've defined the field so it has a default value, we could get away with null. It will just use the default instead, but we might decide to replace it with is null with something like unknown or something like that, right? Then we do our insert, right? And our values come from our parameters. So, but for updated on, we'll typically just use get date. And for updated by, our revised parameter that we've replaced if it was null with the phrase unknown, right? And that's it. That completes the insert. And then we have our select here to basically call scope identity. As long as we have a row count of 1, in other words, we did successfully insert the record, then we'll get the new primary key value, assign that to the output parameter. All right, so let's just see that in our SQL Server. Here's our simple movie one, right? So we have parameters for all of our fields that we're actually inserting data for: title, year produced, review stars, our foreign key, our rating ID, and then there's our output parameter for the integer for the new primary key value. Setting no count off, so we do return the number of affected rows. We do our insert, okay, supplying the values, and away we go. Notice there's no audit, nothing else to worry about here, so that's all there is to it. Assigning the new identity ID value, right, to our output parameter, just as we talked about in our slide. Okay, so pretty straightforward. A little bit more complicated as we deal with our more advanced scenario with concurrency and auditing. Right? Concurrency doesn't play a role in insert, so don't worry about that just yet. But we have our title, year produced, everything else, our 2 foreign keys, and our updated by, which we set to null, so it's optional. Right? Remember, optional parameters have to come after any others, unless except for outputs, of course. So that's why this one comes at the end, right? And then if it is null, we'll replace it. In my case, I decided to use unknown as to who updated it because the system is not providing that information. And away we go. So we do our insert, right? Supplying values for the updated on and updated by. And the updated on gets its value from get date and updated by from our parameter, which we have replaced the value if it was null. Our select to get the scope identity value into our output parameter. Other than that, it's pretty much exactly as per the recipe, just a little bit more complicated. Notice we don't have to worry at all about timestamp because the timestamp field is automatically maintained by the system. So in the insert, it will just actually generate the value for the timestamp and away it goes. All right, our fourth recipe is the update procedure, right? So we'll have all the parameters required. This time we'll include the timestamp as well as anything required in terms of updated by and so on for or created by if you had it for our auditing, right? Again, making it optional with a null. Okay, so jumping ahead there. Sorry, didn't mean to scroll my mouse wheel. All right. So the update statement is as per everything you've been taught. But notice as well, we will again replace in case the updated by was null with something appropriate for our situation. I'm going to go with unknown, right? And then in our sets, as part of the update, we use get date for the dates. For the updated on, do the same thing for created on if you had it, and the updated by, right? But we also have our where clause has two different clauses to it, right? There's the comparison of the primary key to make sure we're updating the correct record, but also a check of the timestamp. So if it's been modified by another user, since this person got their copy, then the timestamp will be different and the update will fail. How will they know then what's going on? Well, with no count to off, they'll get a record or a message indicating that records affected is 0. And that pretty much tells them that, hey, there was a concurrency error. All right, so once more, back into the SQL Server, and I'll just get those up. First, with our simple movie scenario, right? We have parameters for everything that we have to update, right? And there's nothing else to worry about. We set no count to off, so we do return the number of affected rows. Update the movie table. Notice that we don't use the view. You don't try to update the view. It's the actual movie table. The foreign key value is all we need if they did select a different rating, right? So if rating ID number 3 corresponds to PG-13 and that's what they've selected, then that's what we'll get, right? The where clause is just based on identifying the one record to update using the primary key. Okay, now a little bit more complex one then, right? Has all the same information as well as, of course, we have our 2 foreign keys. We do have the timestamp and our nullable updated by, right? Where we set that to unknown if it's null. And in our update command, we set all the appropriate fields as per their parameters, the updated on and the updated by as we've done in the past. But here's again, as we talked about in our recipe, the where clause is both the comparison for the primary key and the timestamp. Okay, almost there. All right, here's our, sorry, I have to click once more, our delete procedure, right? And this is assuming that you are going to do concurrency check on delete, which you may or may decide yes or no, you're not going to bother. We don't need any of the fields, right? We don't care the movie title. All we need to identify the movie by the primary key. That's enough to know which one to delete. But we do need the timestamp if we're going to do concurrency, right? So we set no count to off, so we let them know if a record was affected or not. Delete from the table where the primary key matches as long as the timestamp hasn't changed. Simple, simple. There we go. This is one where there's very little difference between the two scenarios. Here's our simple one, movie delete, right? Passing in the primary key, that's using the where clause, and we delete it if it matches, right? No count off, we'll get a message back of how many records were affected. In the more complex scenario, all we really add is the timestamp, so that is included in the where clause. Again, the fact that we let it know how many records were affected, we can tell whether or not we were able to delete. If the movie had been deleted already, we don't have to worry about that because it'll actually get a database error being raised by the system automatically. Okay, so that pretty much finishes our 5 recipes, right? So now you ready for a bit of extra fun. We did talk about the fact that we might have different versions of select returning stored procedures based on filters. So here's one where a very common filter is for a given foreign key value. So think of, I want to see all the movies that are PG, right? I want to select one in order to put it on for my grandkids and not have to worry about there being bad words or anything in it, right? Okay, or G, for example, right? So if I pass in a integer for that foreign key, the rating ID, right, then I can do my select from my viewer table. By the way, all of our select procedures pretty well always have the exact same projection. The select clause, the fields listed, should be the same in all of them, right? Because we're always going to have the same form up on the screen to display it. So as we make our different select procedures, even the filters, we have the same projection. Okay, so our where clause is where the foreign key matches, but here's a little programmer's trick that helps us to nullify and say return all, without having to switch which procedure we're calling, return all records, right? We put an or that the foreign key matches some flag value, right? The idea of the flag value then is, that we're going to have a certain value we can pass for the foreign key that basically is not something that would ever be in the actual data, but we can use it to indicate, hey, this is what we want to do. We want to return all records. So for example, if we do have an integer identity, okay, then by default it starts at 1, counts up by 1. You can change that seed and increment if you want to, but an integer identity will never have the value 0. So that's a very common flag value. So if I pass 0 for the foreign key, right, then if the foreign key 0 matches 0, well, then the OR clause will always be true. And if an OR clause is always true, then the whole WHERE clause would always be true and all records are returned. So it's a little programmer's trick to make sure that if we pass 0 for in my case, the rating ID, that I get all movies returned, right? So it just makes it easy without having to switch stored procedure to remove the filter. So that's a bit of an example that might be fun to think about. Okay, so we're going to have some homework posted, an exercise for you to work on creating your own 5 standard stored procedures. And this is an important foundation for what we're doing next with our client application. In our case, we're going to use web forms as just one of many examples of different clients that might use the standard stored procedure approach. All right, so have fun and carry on.